Alright, it's Adam again. We are still working on Oppgave 8. This time we're going to be on C. The way that this is set up, it's easier with the shell method, so I'll start with the shell method and do disk method afterwards. So you have the shell method. Same shape as before. Oh, no, I'm sorry, not same shape, same function. F of x is equal to x squared. We are still taking it from that 3 and the 1. But rather than taking around the x-axis, we are taking around the y-axis. When you take this shape here and you go around the y-axis, you're going to end up with kind of like a bowl that has a hole in the middle, or you can think of it like a stadium or a crater or something like that. It's going to have sides that come straight up. It's going to have a flat bottom, but the inside is going to be this bowl shape. But right there in the middle there's going to be a hole, because, you know, as you see, this is going to be the inside sides of the bowl, outside side of the bowl, bottom of the bowl. But right here we're not taking that. We're not taking this section here, so that's going to make a hole in the middle of that bowl shape. So we're trying to find the volume, obviously. We need to find our cylinders. You know, the general description of the cylinder. We need that outside area. So we need the circumference of this outer area, since it's the shell method. The circumference is 2 pi r. This height, so that we can get the outside surface area, because that's going to be our kind of unfolded rectangle shape. So that's going to be times some height. And then the thickness of this, so that we can get a volume instead of just an area, is going to be, you know, these are going to be going this way. Before it was going, you know, now it's kind of like we were doing the disk method as far as which direction that thing's going, because when this goes around that y-axis, you end up with these going around that. If that makes any sense. So yeah, all of these cylinders are going to be around that y-axis, with the y-axis obviously in the middle. So that change, the thickness, is going to be the change in x. It's going to be an infinitely small change in x, so that we get an infinitely small volume. So we call that dx. So we need to find the radius, and we need to find the height. Now the radius of, you know, from here to there, it's going to be from the y-axis to wherever the shell is, wherever that outside section of the shell is. That's just going to be our x-coordinate. So we can just put x. The height is going to be, you know, the height in x, which is simply the function itself, which becomes x squared. So now, remember, we need to have everything expressed in x. That we do have that. We could switch this around, make it y's, like we did in the other, but since we have a dx here, we have everything expressed in x. And that makes this volume 2 pi x squared dx, simplifies down to 2 pi x to the third dx. And then remember, this is just for, that's the volume of this single shell. We want the sum of all of those shells. So we are going to say volume is equal to 2 pi times the integral of x to the third dx. Now remember, we're working with x's, and we want all of these shells from here out here. They're just going to, you know, just sum of all of those shells. So that's going to be from 1 to 3. So 1 to 3. That's I know it's tiny, but whatever. So that is going to give us our volume. we take the integral of that. We get that the volume is equal to 2 pi, put it in brackets, x to the third becomes x to the fourth, divide by 4 gives you a fourth, 3, and 1. Simplify, or actually substitute in for the x, and we get that v is equal to 2 pi times, what is that? That becomes 81 over 4. 3 to the fourth is 81 over 4. 81 over 4. And then we need to subtract if you put in the 1, which is of course just 1/4, because 1 to the fourth becomes 1 times a fourth is a fourth. So now v becomes 2 pi times, 81 minus 1 is 80, divided by 4 is 20, and then v is equal to 40 pi. And that's your volume.